So in this video, we are going to talk about what is log n, that is logarithmic time. You must have heard about that log n is better than log O of n, or which one is having the better performance. Are you getting the better performance with the log n, with on, or on square? So first, let's see what do you mean by O of log n or logarithmic time. So in order to understand that, logarithmic means the runtime increases log arithmetically with the input size. And some example like binary search or the quick sort, you can take that. I'll give you one practical animation example, a very good example of the binary search. And then with this animation, you will understand that what exactly, how exactly this binary search is implemented. So for example, if I refresh this particular entire page, and if you see that there is an array, and the size of the array, you can see it's starting from 0 to 31. It means the size is 32. It means 32 elements are there in this particular array. And I'm looking for example, let's see any element that where exactly it is available. For example, let's see this 88 element I'm looking for, which is available at the 0th position, or maybe 538, which is available on the 19th position. So I have to find out the specific element is available on a specific index or not. If it is not, then return -1. Otherwise, you give me the specific index of that particular element. So how will you do that? So with the binary search, first of all, binary search will work upon the sorted array. Make sure that, okay, your all the elements are already sorted here. And then you can just search for the specific element. So what exactly binary search will do? Binary search will divide this entire array into two parts. For example, let's see if I'm looking for 88, and then first it will divide this entire array into two parts. It means 0 to 31, and 31 divided by 2, which is giving you 15 over here. And then now we have to check the element either before 15, it means between 0 to 14, or between 16 to 31. And then on the basis of some condition, we will decide, okay, fine, I'll go with the left hand side part. It means from 0 to 14, I'm going to look for that particular element. And then again, I'll divide this entire array, now 0 to 14, into two parts. And then again, the size will be in that case 7. Then again, I'll check I want to go to the left hand side or the right hand side. Then in that case, I'll again divide that particular array from 0 to 7 into two parts. Then we are getting, let's see, 4, 4 to 2. And then finally, we are getting 88 over here. So you will get a better understanding when I show you in this particular animation. For example, let's start with the 88 with the binary search, not with the linear search. And then let's click on binary search. And here you can see we are looking for element is 88. So see, first it is actually dividing into two parts. Now element is from 0 to 14. Again, it will be divided into two parts. Now 0 to 7. Then again, it will be divided into two parts. That is now between 0 to 3. Again, it will be divided into two parts, like 4 divided by 2 is equal to 2 now. Now between these two elements are available. Then again, the array size is 2. And then finally divided by 2 once again. And then finally, we got that particular element. So how many iterations that we have performed? It's not like we are performing each and every value that we are checking from 0 to 31. So it's not like we are writing a loop from 0 to 31 or 31 times that we are iterating over here. Let's take some other number. For example, let's see if I'm looking for 678 over here. So I'll start with, okay, 678 and click on binary search once again. So again, this is the lowest index. This is the highest index. We are looking for 678. First, again, it will be divided into two parts. Then it will decide, okay, fine, I'll go to the right-hand side part and then again divide it into two parts. Then again, divide by two parts. So it will keep dividing. Then it will decide, okay, fine, I'll again go to the right-hand side part. Now the cursor will move to the right-hand side part. And then finally I got again divided into two parts. And then finally I got 678 over here. So hardly 3 to 4 iterations I have performed just to find 678. That's why it's giving you the element 678 is found actually on index number 22, right? If the specific element, let's see, available at the last index, let's try with the 907 as well. Let's go with that. With 907, again, lowest index, highest index, entire array will be divided into two parts. Now we have decided, okay, fine, we will go with the right hand side. Again, it will be divided into two parts. Now we just need to look into that particular array. That's it. And then again, keep dividing into two parts. So every time we are dividing the entire array by 2, then again, the size is now 4, 4 to 2, and then 2 to 1 finally. And then after 2 to 1, we are finding that element is available at 31st index over here. And then the 31st index will be returned over here. I'll tell you the logic how exactly it is working. Now let's see if element is not available at all. I'm looking for, let's see, 8777, something like this. And then I'm going for the binary search. So let's see how many iterations it is performing. Again, divide by 2. Then 8777 is actually greater than the mid element. Then it will go to the right hand side. Again, divide by 2. Then again divide by 2. So now from 27 to 31, it will go and check. Again divide by 2. Okay, now we have only 4 elements. 4 divided by 2 is equal to 2. Then again, finally 2 elements are left. I mean 2 indexes are left. And then we have reached at the last element also. Now I cannot divide by 2. Then in that case, I did not find anything. Then in that case, it will return -1 over here. It will say element not found. So how exactly this particular algorithm is working? Now let's see, I have an array. For example, let's see, this is the array that I have. And make sure that, guys, that this is the array which is already sorted array. Okay, so binary search will work always on the sorted array. Sorted array means the elements are already sorted. For example, let's see, I have some elements like 1, 2, then 3, 4, let's see, 5, 6, 7, 8, and then let's see, 9 is also there. And then these are the 9 elements are available here. And then you see this is 0th index, first, 2, 3, 4, 5, 6, 7, and 8. So in binary search, what exactly we have to do? First of all, that we have to check, okay, fine, I'll take 2 variables. Let's see, low variable. That is the lowest index is always 0. Then I'm going to take, this is my highest index, which is equal to what? Whatever the array length is there, the array length dot -1 that I'm going to take. So this is my lowest index and this is my highest index. So I'll take, okay, fine, this is my whatever the array dot length -1. In that case, this is my highest index. So this is giving you 8 over here. Okay. Then I'll do one thing. I'll start writing a simple, let's write a pseudo code. I'm going to write a while loop. And inside this particular while loop, I'm going to write if low variable is less than equal to high. Okay, until this, I have to start a loop here. Then I'll what exactly I'm going to do that. First, I have to calculate the mid of this particular array. So mid of this array is what? How will you calculate? So let's say I'm going to take one variable, integer mid, which is equal to what? Integer mid is equal to whatever your lowest number and then the highest index number, that is divided by 2, right? That will give you the mid. So in that case, 0 plus 8 is equal to 8 divided by 2. So this is my mid now. So I'll say, okay, fine, this is my mid. So mid is pointing to at this. It means mid is pointing to 5 and then the index is equal to 4 over here. I'll put a condition immediately that if my first condition that I'm going to write, that if this particular mid is equal to the number that you are looking for. Let's see, the number that I'm looking for is equal to, let's see, 1. I'm looking for this particular one, right? So if is equal to x, then in that case, so for example, let's see, 1 is directly available over here. Then in that case, I got my element and that's it. I don't need to proceed further. I immediately say, okay, fine. Then you return what? Return the mid, return the same index over here. It means mid is equal to 4 in that case. So immediately you return 4. It means 1 is available on the 4th index, but my 1 is available over here. But it could be anything, right? Just 1 is available over here also. That is also possible that 1 is available here as well. Okay. So let's say if immediately we found the specific element on the mid position, then immediately you return the mid. Then I'm saying, okay, fine. Then otherwise, what do you do? Otherwise, you write one more else if over here. And then I'm checking that if array of mid. What is array of mid? Array of mid is what? Let's see, this is in this case, in this example, the array of mid is 5. Then I'm checking that if 5 is less than x, the number that you are looking for, we are looking for x is equal to 1 over here. So 5 is less than 1. No, 5 is not less than 1. Then in that case, just ignore this particular condition. But let's see if I'm looking for 9. If x is equal to 9, then in that case, 5 is what? Less than 9 in that case. If it is less than 9, then what should I do? Then I have to go in this particular direction. Then after mid, I have to start. So in that case, what should I do? Right now, the low, this low index is pointing over here, and the high index is pointing over here. This is my highest index, and this is my lowest index. So what I'll do, I'll just shift this particular low over here. It means shift this particular low to mid plus 1. So in that case, that's what, if the condition, this condition is satisfied, I have to go to the right hand side. This arrow means right hand side we have to go. It means then you do what? Then you write the low is equal to what? Mid plus 1. Okay. But else if your array of mid is what? If array of mid is greater than x, it means, let's see, in that case, if you are looking for 1, then in that case, what? Array of mid initially was 5. 5 is greater than 1. In that case, what? In that case, yes, this condition will be satisfied. Then in that case, I know that, okay, I have to go to in this particular direction. So what should I do? It means this high, I have to shift it over here. So I'll say, okay, fine, high, you come here. It means mid minus 1 that I have to write. So in that case, I'll write mid minus 1 over here, right? Because the high mid initially was pointing to 5. So mid minus 1 is equal to 4 now. So that's what high is equal to mid minus 1. In that case, I'll be writing high is equal to what? Mid minus 1, right? And then if it means I have to go in this particular direction, in the left direction. Then in that case, if once the while loop is done, I found that particular element, but let's see that element is not at all available over here. Then after the entire while loop from here to here, then you say, okay, fine, you return minus 1. In that case, element is not found. So this minus 1 will say, okay, fine, element is not found in this particular array. Let's say I'm looking for 11. 11 is not there, right? So in that case, let's check this particular pseudocode. Is it really working or not? So I'm looking for 1 over here. Okay, so I'll check, okay, that mid is equal to what? So in that case, my mid is equal to 4. You can see mid is equal to 4 according to this algorithm. Then I'm checking 4 is equal to 1. No, 4 is not equal to 1. Then go to this particular else if. Then it's saying that array of mid is what? 4 is greater than 1. Yes, this is satisfied. It means where? Here you can see that this particular condition will be satisfied. It will not go to this particular condition because 4 is not less than 1. It will go to this condition. 4 is greater than 1. Yes. So it means high index is equal to mid minus 1. So what is my high index? Mid is what? 4 minus 1. So in that case, high will start pointing over here. Perfect. So what is the value of high? High is equal to 3 now. And what is the low? Low is equal to 0. So again, it will go and check. Again, the while loop will start. It will check low less than high. Yes, low is still less than high. 0 is less than 3. It will go and check, okay, what is the next value of mid? The next value of mid is equal to what? Again, 3 plus 0 divided by 2. It means 3 divided by 2, which is giving you what? Which is giving you 1 over here. Okay, 1.5 means 1 because 0.5 will be ignored in that case. So 3 divided by 2 is equal to 1. It means mid is pointing to where? Mid is pointing to the 2 over here. Then again, it will be divided by 2. And then finally, I got this particular element here. So like this entire algorithm, how many iterations is actually performing in that case? So if you really calculate, if let's see, for example, if there are, let's see, if there are 32 elements are there, then how many iterations are there? It means length of the array is equal to 32 in that case. So every time we are dividing by 2. So let's see, this is the length is equal to 32. So I'll say, okay, fine. First, you 32 divided by 2 is equal to what? 16 in the first iteration. Then again, in the second iteration, the 16 is again divided by 2, which is equal to 8 in the second iteration. Then in the third iteration, again, 8 divided by 2 is equal to 4. Okay. Then in the fourth iteration, again, 4 divided by 2 is equal to 2. Just keep dividing it. 4 divided by 2 is equal to 2. And then in the fifth iteration, 2 divided by 2 is equal to 1. And then your element is actually found over there. So in that case, how many iterations we have performed? 1 to 5. It means 5 iterations we have performed if the array size is 32. So if array size is 32, can I say it is actually 2 to the power 5, it means 5 iterations it is performing on the base of 2. So same thing if I'm asking that, okay, for 1024, how many iterations it will perform? It will perform around 2 to the power 10. It means 10 iterations only. So if the size of the array is 1024 elements are available, then it will perform only 10 iterations to find that specific element maximum it will perform. Then same case, if there are 32,768 elements are there, then it will perform only 2 to the power 15. It means 15 iterations it will perform maximum it will. That's it. So such a nice optimized solution, a search algorithm that we have in that case. So if you really want to generalize the formula, how will you generalize how exactly we can say this is O of log n? Because, for example, let's see, number of iterations are denoted by k. So I'll write, let's see, number of, in this the same formula, iterations is equal to k, right? So I'll say that if there are n input size, what we do, divide by 2 always, divided by 2 to the power k is equal to 1. We can say like that. Or if you simplify the formula, then we can say that n is equal to 2 to the power k. It means when you perform, see this 2 to the power k, this is also k, this is also k. So I'm just defining a generalized formula. It means 2 to the power k is equal to what? Number of elements, which is equal to n. So that is what I have written. 2 to the power k is equal to n. I have written. Fine. Then if I take the log both sides, so I'll say, okay, this is a log of n, which is equal to log of 2 to the power k. And I can again simplify this. I'll say, okay, this is log n is equal to what? I can say k log 2 here. And let's see, both the sides, the base is 2. So I'm applying the base 2 over here like this. So can I say that the overall time complexity is what? The overall time complexity, I can say k is equal to how many iterations it is actually performing. It is performing log base 2 n iteration it is performing. Now this is what the time complexity like this. So if you write it like this, n by 2, then n by 4, then n by 8. So can I generalize that? Okay, n 2 to the power 0, n divided by 2 to the power 2, then n divided by 2 to the power 3 like this. So that's what I'm saying, n 2 power k is equal to 1. So n is equal to 2k. And like that, if I take both the sides log, so finally we are getting log of n over here. So if you see the simple binary search method over here, that is what I have written. It's taking, okay, you give me the sorted array and give me which element that you are looking for. And such a simple algorithm, lowest index is equal to 0, highest index is equal to array length minus 1. And then I'm checking if low less than up to less than equal to high. And then first of all, immediately you find out the mid. Mid is equal to what? Low plus high is equal, divided by 2. And then I'm checking if array of mid is equal to x. It means that element that I'm looking for, it's available in the mid position. In that case, in the best case scenario, you simply give me that mid position and return mid, and that's it. But if it is not available, then you check the next condition, that if array of mid is less than x, in that case, it means if less than x, then you have to go to the left direction. Otherwise, you have to go to the, it means low is equal to mid plus 1. Otherwise, high is equal to mid minus 1 over here. And that's it. So then if nothing is getting satisfied after the entire while loop, you simply return minus 1 here. So for example, let's say if I have a specific array, for example, I have this array, and then I'm calling this particular function binary search. So let's see, is it really working or not? I'm calling binary search. This is my array, and the X that I'm looking for, let's see, 3. And 3 is actually available 0, 1, and 2. So it should give you 2 over here. Right? So I'll store in some integer. Let's see, ix is equal to this. This is the index number of 3. So let's see, ix should be what? 0, 1, 2. Let's see, is it really giving you 2 or not? So now you can see it's giving you 2. If you're looking for, okay, fine, give me the index of something, let's see, 5. Then in that case, it's giving you 4. If you keep adding more numbers here, let's see, I'm adding 10, then 11, then 606. Then in that case, 14. Perfect. So this algorithm is absolutely working fine. This algorithm is a binary search algorithm, which is giving you the big O of log n time complexity. It will give it to that. Okay, perfect. But let's see if you are not having the sorted array. For example, let's see if you are having unsorted array. Then in that case, first you have to sort it and then only you can do that. So for example, let's see, I'm just going to comment it out. At a time of interview, if you are having the unsorted array, this logic will not work. It might give you the wrong result. So first you have to use what? Arrays class dot sort method. You can use it, pass the array. First you sort it and then apply the binary search over here. So then you apply the binary search. Okay, so first you sort it and then you apply for that. So let's see, I'm looking for once again 6. Then in that case, first it will sort and then the 6 is the last element, means available on the 5th position. Okay, okay, over here that we were discussing about where exactly the log n will go. The log n will go to the right. So if you draw the O of log n, it will give you logarithmic graph, which is like somewhere better than O of n. So if you really draw this, it will go in this direction like that. So let's see, I'll just pick some other color this time, this one, and then it will go like this. Okay, somewhere over here, and then you just slightly, okay, and then it will just, after more and more elements, let's see if tomorrow, if you have 32, 768 elements are there, it will just perform only 15 iterations. So you have to draw the graph accordingly like this, and just below the O of n that you have to draw it. Remember this thing. Don't draw the O of log n over here. Okay, not at the left hand side of O n. It will always be the right hand side of O of n.